10 rarest and most legendary classic pickup trucks ever built. What if one of the most valuable vehicles in American history wasn't a supercar, but a work machine built to survive mud, timber, and unpaved roads? Across the last century, a small number of trucks didn't just perform well. They redefined what engineers believed a utility vehicle could be. Some introduced drivetrain concepts still used today. Some solved problems competitors didn't even know existed yet. And one became so rare that even experienced collectors debate how many are still left in the world. These machines didn't chase attention. They earned reputation through function, durability, and mechanical decisions that shaped entire industries. From early torque-focused work platforms to a regulatory loophole that unexpectedly created one of the fastest production vehicles of its era. These are the trucks that carried more than cargo. They carried turning points in engineering history. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, Ford Model TT, the truck that taught America how to move industry. Before trucks became symbols of capability, they were simply experiments trying to survive work they were never designed for. In 1917, Ford introduced something radically different, the Model TT. At first glance, it looked familiar, but underneath it represented one of the earliest purpose-built work platforms ever mass-produced. Instead of modifying a passenger car and hoping it could survive heavy labor, Ford reinforced the chassis, altered gearing for torque rather than speed, and implemented a worm-drive rear axle designed specifically for load resistance. Its rated 2,000-pound payload may sound modest today, but at the time it allowed farmers, builders, and suppliers to transport materials across terrain that would destroy lighter vehicles. Speed was never the objective. Reliability under continuous stress was. With a recommended top speed of roughly 15 miles per hour, the Model TT prioritized durability over velocity, a decision that shaped the philosophy of commercial vehicle engineering for decades. Sold primarily as a bare chassis, it enabled custom cargo bodies tailored for agriculture, delivery, and emergency response. More than 1 million units were produced before 1927, but its real legacy was conceptual. It proved that work vehicles needed to be engineered for labor from the very beginning, not adapted later. And once that idea took hold, the entire industry began to evolve around it. Ranked 9th, Ford F1, when trucks stopped feeling like modified cars. By the late 1940s, the world had changed, and expectations for machinery changed with it. After World War II, returning industries no longer needed vehicles that merely survived work. They needed machines engineered specifically for it. In 1948, Ford introduced the F1, a truck built on a fully dedicated truck platform rather than a reinforced passenger car frame. That distinction may sound subtle, but it marked a fundamental engineering shift. The chassis geometry, suspension configuration, and weight distribution were designed from the outset to handle repeated load stress without compromising stability or drivability. Ford widened the cab, repositioned the steering column, and improved seat construction. Early signs that trucks were evolving beyond pure utility. Under the hood, buyers could choose between the reliable inline-six or the increasingly respected flathead V8, delivering a balance of usable torque and road capability. The F1 didn't just improve durability, it changed how manufacturers approached the entire category. Trucks were no longer secondary products derived from passenger vehicles. They were becoming their own engineering discipline. And once comfort entered the equation, the role of the pickup truck began to expand far beyond the job site. Ranked 8th, Chevrolet 3100. The moment utility gained identity. Rounded steel replaced sharp edges. Visibility improved without adding complexity. Proportions became balanced enough that the vehicle no longer looked assembled purely for labor. When the Chevrolet 3100 arrived as part of the Advanced Design Series, it signaled a subtle but important shift in how work machines were perceived. Operators were spending longer hours behind the wheel, navigating tighter loading areas, and using trucks for more than a single repetitive task. The optional 5-window cab increased rear awareness, improving maneuverability in confined work environments. Inside, refinements such as improved airflow systems and more structured dashboard layouts made extended use more practical. Power came from the durable Thriftmaster Inline 6, not designed for speed, but trusted for consistency under repeated mechanical stress. The 3100 did not change the definition of capability. It changed the expectation that capability should also feel intentional. Utility machines were no longer required to appear purely industrial. They could present structure, balance, and clarity of design while still performing demanding physical work. And once appearance began influencing operator preference, the evolution of trucks accelerated again. Because function alone was no longer shaping decisions, perception had quietly entered the engineering process. Ranked 7. Ford F250. Highboy, when ride height became capability. A taller stance was not originally intended as a styling decision. It was the mechanical consequence of solving a geometry problem. To accommodate a solid front axle, leaf spring suspension, and a divorce transfer case, Ford engineers raised the truck's frame higher than its two-wheel drive counterparts. The result was a platform that sat noticeably above typical pickup proportions, later earning the nickname Highboy. Produced between 1967 and 1977, these factory 4x4 F250 models delivered ground clearance that allowed operators to run larger off-road tires without structural modification. Dana front axles provided durability under uneven load distribution, making the truck particularly effective in logging environments, construction zones, and undeveloped terrain. The Highboy did not rely on cosmetic aggression. Its appearance reflected mechanical necessity. Increased ride height improved obstacle clearance, approach angles, and load stability across unpredictable surfaces. The design communicated something immediately. This machine was engineered to operate where standard vehicles would hesitate. And once elevated geometry proved its practical advantage, expectations for off-road capability permanently shifted. Because ground clearance had become more than a measurement, it had become a performance category. Ranked 6th. Ford F-15 O-Ranger XLT, when utility began competing with comfort. At some point, the role of the pickup truck began to expand beyond the job site. Operators were no longer using trucks only during working hours. They were driving them into towns, onto highways, and into everyday routines. Ford responded by introducing trim levels that treated the interior environment as seriously as the mechanical platform itself. The Ranger XLT package represented one of the earliest moments when comfort features were intentionally integrated into a vehicle still expected to perform demanding physical work. Carpeted flooring, upgraded seating materials, refined trim surfaces, and improved cabin ergonomics signaled a shift in design priorities. Underneath these refinements remained engines capable of delivering substantial towing capability, ensuring performance expectations were not reduced. This combination demonstrated something manufacturers could no longer ignore. Buyers no longer wanted to choose between capability and comfort. They expected both. The Ranger XLT helped establish the modern expectation that a truck could operate as a work platform during the day and transition seamlessly into everyday transportation afterward. Utility had not disappeared. It had expanded its role. Ranked 5th. Chevrolet Cameo Carrier, when one material decision challenged tradition. Steel had defined truck construction for decades, durable, predictable, and familiar to manufacturers. So when Chevrolet introduced smooth fiberglass bedside panels on the Cameo Carrier in 1955, the decision raised more questions than excitement. Fiberglass was associated with experimental applications, not working vehicles expected to endure constant load stress. Yet engineers pursued the idea to create a fully integrated bed profile that eliminated the exposed step-side structure common at the time. The result was a cleaner, more continuous body form that aligned the truck visually with contemporary passenger vehicles. Underneath the refined exterior remained proven V8 performance, ensuring the platform retained its working capability. Market reception was cautious. The Cameo's higher cost placed it outside the reach of many traditional buyers, limiting production volume. But the long-term influence proved significant. The flush-side bed configuration introduced here would eventually become the dominant design approach across the entire pickup segment. A decision once viewed as unconventional quietly reshaped the visual language of utility vehicles for generations. Ranked fourth, Dodge Power Wagon, capability proven. Where failure was not an option, some machines are designed for efficiency, others are designed for conditions where failure carries real consequences. The Dodge Power Wagon emerged from engineering principles originally developed for military transport. Environments where traction, torque delivery, and structural strength determined whether equipment reached its destination at all. Introduced for civilian use after World War II, the platform retained much of the mechanical philosophy that had proven reliable under extreme operational stress. A robust inline-six engine prioritized low-end torque rather than high-speed output, allowing the vehicle to maintain controlled movement across uneven surfaces and unstable ground. Factory-equipped four-wheel drive and available power takeoff winch systems extended the truck's functional range beyond conventional transport roles. Operators could recover equipment, traverse undeveloped terrain, and maintain forward movement in conditions that would immobilize standard vehicles. The Power Wagon demonstrated that durability engineered for wartime necessity could transition effectively into agricultural, industrial, and infrastructure environments. Strength was no longer a specialized requirement. It had become a civilian expectation. And once extreme reliability entered the commercial market, baseline capability standards moved permanently higher. Ranked third, NAPCO 4x4 Chevrolet, when capability came from outside the factory. Sometimes the most influential engineering solutions do not originate from the manufacturer itself. During the early 1950s, Chevrolet did not yet produce a factory four-wheel drive pickup, yet demand for improved traction in mountainous terrain, remote utility routes, and undeveloped agricultural regions continued to grow. NAPCO, the Northwestern Auto Parts Company, introduced a highly engineered conversion system known as the Power Pack, allowing standard two-wheel drive Chevrolet trucks to be transformed into fully capable four-wheel drive machines. The system incorporated a dedicated transfer case, reinforced driveline components, and a front drive axle designed to distribute torque across unstable surfaces. Installation required minimal structural alteration, enabling dealers to adapt existing platforms efficiently. These converted trucks became valuable tools for forestry crews, infrastructure operators, and farmers working in areas where surface conditions could change rapidly. By the late 1950s, the effectiveness of the system became difficult for manufacturers to ignore. Factory-installed four-wheel drive systems soon followed. A solution originally developed outside the production line ended up reshaping expectations inside it. Adaptability had proven just as valuable as raw mechanical strength. Ranked second, Dodge Lil Red Express, when regulation accidentally created performance. Engineering progress does not always come from adding capability. Sometimes it comes from navigating limitation. During the late 1970s, tightening emissions regulations had significantly reduced the output of many American V8 engines. Performance vehicles were becoming increasingly restricted by catalytic converter requirements designed to control exhaust output. Dodge engineers identified a narrow classification detail within federal vehicle weight regulations. By configuring the truck's gross vehicle weight rating above a specific threshold, the platform qualified for a different emissions category, allowing the engine to operate without the same exhaust flow limitations applied to many passenger cars. The result was the Lil Red Express, equipped with a modified 360 cubic inch V8 derived from police interceptor configurations. The truck delivered acceleration figures that surprised both consumers and industry observers. Period testing revealed performance levels capable of competing with contemporary sports cars, an unusual outcome for a vehicle originally categorized as a utility platform. The vertical exhaust stacks were not merely visual identifiers. They reflected a mechanical system allowed to operate with fewer restrictions than many performance vehicles of the same era. An unintended intersection between regulation and engineering had produced something unexpected: a work-class vehicle capable of outperforming machines designed specifically for speed. Constraint had not limited innovation, it had redirected it. In first place, Diamond T Model 201. When utility reached the level of craftsmanship, scarcity alone does not create legend, precision does. Between the late 1930s and late 1940s, Diamond T produced a pickup that approached utility engineering with a philosophy rarely applied to working vehicles: uncompromising build quality regardless of cost. The Model 201 combined heavy-duty structural integrity with design refinement typically reserved for premium passenger automobiles of the era. Complex chrome detailing, flowing fender geometry, and carefully balanced proportions reflected an attention to form unusual for commercial equipment. Inside, features such as a banjo-style steering wheel, integrated instrumentation, and refined trim materials demonstrated a level of finish not commonly associated with load-bearing platforms. Beneath the exterior, a robust Hercules inline-six engine delivered reliable torque through a heavily reinforced chassis engineered for long service life. Production numbers remained limited due to the vehicle's elevated cost relative to mainstream alternatives. As a result, surviving examples became increasingly rare within collector circles. The Model 201 illustrated a distinctive idea. A work vehicle could be engineered with the same level of craftsmanship applied to prestige automobiles. Strength and refinement did not need to exist separately. They could be developed together, and when they were, the result was not simply a machine, it became a benchmark. Engineering doesn't always look revolutionary in the moment. Sometimes the biggest shifts happen quietly, inside drivetrain layouts, material decisions, and design philosophies that later become industry standards. Many of the ideas introduced by these trucks still exist in modern work machines today, just refined, just scaled, just easier to overlook. Which of these platforms still feels relevant in today's working world? Because some engineering decisions never truly disappear. They simply evolve.